In this video, we're going to build a wheel robot that we can control from any device over Wi-Fi. We'll use an ESP8266 development board and some custom hardware to put together the robot. We'll rewrite some Arduino code from another video so that we can control the robot and give it commands to drive in different directions using Websockets. For controlling it, we'll use HTML elements and JavaScript code, which will be served to any controlling device as a very simple web page. Alright, let's do this. This video is sponsored by NextPCB. They're currently offering a free PCB prototype with your first order. The ordering process on their website is pretty straightforward. They offer a wide variety of options, and with their current promotions, you can get 5 prototypes for free. They're both ISO 14001 and 9001 certified, so they produce really high quality boards. Besides their manufacturing services, they also cover the processes of sourcing components, PCB manufacturing, assembly, testing, and final shipment. For this video, we'll use the WeMos D1 development board for the ESP8266. We'll also use an Arduino motor driver shield, a couple of DC motors with their respective mounting brackets. We'll also use a couple of 42mm wheels and a custom chassis that I've laser cut from acrylic. To power the robot, I'll just use 2 USB batteries that are easily found online. As usual, I'll leave a link to all of these products in the description of the video. Most of them you can find in my little Amazon shop. Assembling the robot is pretty straightforward. You're welcome to follow along or skip ahead if you're more interested in the software side of things. With the robot assembled, we can navigate to our ESP8266 demos repository and download it onto our computer. To save a little bit of time, I'll make a copy of a previous sketch where we build a turntable controlled by Websockets. I'll rename it as WebServer RC Robot. As we'll be using DC motors instead of stepper motors, I'll get rid of pieces of code that I don't need. I'll also add the very useful Arduino JSON library for parsing data in JSON format. Now let's make sure that all the necessary libraries are installed. Using the Tools menu option, I'll open the Manage Libraries and install the WebSocket library, the Adafruit Motor Shield library to control the motor shield, and lastly the Arduino JSON library. Next thing I'll do is fill in my network credentials. I'll then define an object for both the left and the right motors, and in the setup function I'll set an initial speed for both of them. Notice that I don't need to do anything to the routes that were defined for the web server in the turntables example. What I need to do is go into the WebSocket event function and modify the code according to the needs of this project. Specifically, I will be sending from the client side a speed and direction in which I want the robot to move. The data will be formatted in JSON, so I'll use the Arduino JSON library to parse it. The way this is done in the latest versions of the Arduino JSON library is by calling the deserialized JSON function on the JSON string. To remind ourselves how that string is sent to the web server, let's open up the HTML page that will be served to clients that are controlling the robot. Using JavaScript, we establish a WebSocket connection between the client and the ESP8266 server, and we transmit data using that WebSocket connection. For controlling the robot, I'll want to have a way of telling it the direction that it needs to move, as well as the speed. For the sake of brevity, I won't go through the details of how to write the code step by step, but rather I'll go over the details. I'll be using 4 buttons, each one for setting a different direction of the robot, and a slider similar to the other example where we set the speed of the robot. If we open this page on a browser, we can see what it would look like when served by the ESP8266. When this piece of code is actually served to any client, the way the JavaScript works is by first calling a function that I've called mcinit. In this function, we create the WebSocket connection, and then we add actions to each one of the direction buttons so that when they're clicked, they either call a move function or a stop function. When the button is clicked, we'll send a WebSocket message for the robot to move, and when the button is unclicked, we'll send a WebSocket message for it to stop. The messages themselves contain a JSON formatted string specifying what we want the robot to do. Now, if we go back to the Arduino IDE, we can add the necessary logic for moving the motors according to the message that we receive on the WebSocket. But before heading into deeper waters, let's just see if we can at least receive the WebSocket messages and print them to the serial monitor. Let's go ahead and connect the robot to the USB port of our computers. With that done, I'll go through the Tools menu and select the correct board and USB port for our setup. In addition, remember to set the flash size option so that it allows for us to have an SPI flash file system. I'll select the 2 megs for the SPI FFS. Now when we upload the code, we're able to load that HTML file onto the flash file system of the ESP8266. If I now go onto my browser, navigate to that IP address, I should see it served to this client. Then I can verify that the file was indeed uploaded, and if I press any of the buttons, I should see that the JSON formatted string was sent to the server and it's being parsed and the direction being printed. If we go back to the JavaScript code, we can perhaps understand it a little bit better. We can see that the messages are constructed by the ID of the HTML elements, which I've specified to contain the string that specifies the direction. So now if we go back to the Arduino code, we know what strings to expect in order to move the robot in a certain direction. So in the case that that string contains the characters STP, we want the robot to stop. Otherwise, we can parse the string and extract both the speed and the direction in which we want the robot to move. As a preference, I have the slider go from 0 to 100, so I need to scale it to the actual speed that we can specify on the server side of things. Once we have that speed scaled, we can send it to the motors and then move the robot according to the direction that was specified. So if the direction string contains the characters FWD, we want both motors to move in the forward direction. As a sanity check, let's go ahead and test the code right now. I'll need to turn on the battery powering the motors, upload the code, and if everything goes according to plan, whenever I click the forward button, the robot should move forward. Now if I go back to the Arduino code, I can specify what I want the motors to do for all other directions. With those changes made, I can go ahead and upload the code, then I can unplug the robot from the USB port of the computer and power it using the second battery. Now if I go to my browser, I can test out all the different directions. But what's even more entertaining is that I can pull up my mobile device, go to the IP address of the ESP8266 and use it to drive around the robot. I can even set a faster speed if I wanted to and just drive it around for fun. So there you have it. We've successfully built a little wheel robot using an ESP8266 that's able to be controlled in real time from any mobile device using Websockets.
If you like my videos, I invite you to my Patreon page where you can chip in a buck or two. That really helps me put in more time into the videos and release them quicker. But whatever you do, don't forget to like, subscribe, or leave me a comment. You can also interact with me on social media. I'm on Instagram, Twitter, and Facebook, and you can even use the community tab of the channel. Thank you for watching my videos, and I will see you next time.